An axial compressor stage has the following data. That is, the temperature and pressure at the entry is given as 300 Kelvin and 1 bar. Degree of reaction is 50%. Mean blade ring diameter is given as 36 centimeter. Rotational speed, that is, the rotational speed is given as 18,000 RPM. Blade height at the entry is 6 centimeter. Air angle at the rotor and stator exit is 25 degree. Axial velocity is 180 meter per second. Work done factor is 0.88. Stage efficiency is 85% and mechanical efficiency is 96.7%. They have given all this data, and we need to determine the air angle at the rotor and stator entry. That is, we need to find the air angle at the rotor and stator entry. This we should find. That is, we should find beta 1 and alpha 1 value. Okay. The mass flow rate. That is, we need to find the value of m dot, and here we need to find the value of alpha and beta. The power required to drive the compressor, where we should find the value of P, which is the power, and the loading coefficient, which is given by this side. We need to find this, and the pressure ratio developed by the stage, which is being developed by the stage, which is given by delta TA, and the Mach number at the rotor entry, and we should find the Mach number at the rotor entry. We should find the value of m, which is nothing but the Mach number at the rotor entry, MW1. We should find all these data. Now let us find the air angle at the rotor and stator entry. We will find the air angle at the rotor and stator entry. Now, from this velocity triangle, if you take tan alpha 1, this tan alpha 1 is nothing but opposite side by adjacent side. Here the opposite side is CY1 and the adjacent side is CX1. Now, therefore, tan alpha 1 will be equal to CY1 divided by CX1, and we can write that equation. That is, tan alpha 1 is equal to Cx divided by Cy1. This is C1. We know that for an axial stage compressor, Cx1 is equal to Cx2, which is equal to Cx3, and we will be considering it as Cx. Therefore, the value of Cx1 is equal to Cx2, which is equal to Cx3, and this will be equal to Cx. Therefore, I will be mentioning it as Cx. Okay, I will be mentioning it as Cx divided by Cy1. Therefore, the value of Cx will be equal to Cy1 into tan alpha 1. Cy1 into tan alpha 1. Now, if you substitute these values in this equation, you can get the value of Cy1 as that is this equation. From this equation, the value of Cy1 is equal to Cx divided by tan alpha 1. Okay. From this, you can get the value of Cy1 as 83.935 meter per second. Okay, we will be getting a value of 83.935 meter per second. In the same way, the value of W1 will be U minus Cy1. The value of, we should find the value of U before getting the value of Wy1. Therefore, you should find the value of peripheral speed. That peripheral speed is given by an equation, that is Wy1 will be equal to Cy1 u1 minus cy1. That is wy1 will be equal to u1 minus cy1. This you know that value of u1 is equal to u2 is equal to u. Okay. Therefore, from this you can attain an equation wy1 is equal to u minus cy1. Okay, we have find out the value of cy1 and you should find the value of u in order to get the value of wy1. Now substituting that equation, wy1 is equal to u minus cy1. Here the value of u is unknown, so you should find the value of u, which is given by u is equal to, we know that the peripheral velocity is given as pi dn divided by 60, pi dn divided by 60, which is equal to pi into 0.36 into the n is given as 18,000, which is 18,000 divided by 60. From this, on calculation, the value of u will be equal to 339.292 meter per second. Okay, you will be getting the value of u is equal to 339.292 meter per second. And now substituting the value of u in this equation, you can attain the value of wy1. That is, the value of wy1 is equal to u minus cy1. The value of u is 339.292 minus cy1, as we have already found, it is 83.935. Therefore, substituting that value, you will be getting 83.935. Okay. wy1 is equal to that 339.292 minus 83.935. You will be getting this equation. Now, on calculation, the value of wy1 will be equal to 255.357 meter per second. You will be getting the value of wy1 as 255.357 meter per second. Okay. Now we should find the value of beta 1. We should find the value of beta 1. That is, in the velocity diagram, in the stage velocity diagram, you should find the value of beta 1. This beta 1 is nothing but, if you take tan beta 1, then it will be opposite side by adjacent side. This here, the opposite side is wy1 and the adjacent side is cx. Therefore, if you take tan alpha, tan beta 1, this will be equal to wy1 divided by cx. wy1 divided by cx. Now substituting the value of, that is, tan beta 1 tan beta 1 is equal to wy1 divided by cx. We have arrived this equation from the stage velocity triangle, and we know the value of w1, which is value of w1 is equal to 255.357 meter per second, and we know the value of cx. By substituting both these values, you can attain, that is 255.357 divided by the value of cx is, the value of cx is 180. The value of cx is 180. Therefore, on calculation, you will be getting a value of 1.418. Therefore, tan beta 1 is equal to, that is, value of tan beta 1 is equal to 1.418, and the value of beta 1 is equal to tan inverse of 1.418, which is equal to 54.82 degree. That is, we have find out the value of beta 1, which is equal to 54.82 degree. That is, tan, we have taken tan beta 1 is equal to wy1 divided by cx from the velocity triangle, and we have substituted the value of wy1 as 255.357 and the value of Cx is 180, and on calculation you will be getting 1.418, and this tan beta 1 is equal to 1.418 and beta is equal to tan inverse of 1.418 gives the value of 54.82 degree. Okay, this is how we have attained the value of beta 1. Here the stage has 50% of reaction. In the axial compressor, the stage has 50% reaction. 50% reaction. Therefore, the value of alpha 2 will be equal to beta 1. The value of alpha 2 will be equal to beta 1, which is equal to 54.82 degree. This we have already seen while deriving the equations, the derivation equation for efficiency and in the stage velocity triangle, and the value of alpha 1 is equal to alpha 3. This too we know that the value of alpha 1 is equal to alpha 3, which is equal to beta 2, which is equal to 25 degree. That is, here in the question you can see air angle at the rotor and the stator exit. That is, air angle at the rotor and stator exit is given as 25 degree. Therefore, the value of alpha 1 is equal to alpha 3 is equal to beta 2. This is at the entry. This is at the entry of the rotor, and this is the stator. This all will be equal, and it is equal to 25 degree. This is from the given data. The air angle at the stator and the rotor exit is 25 degree, and the degree of reaction is equal to 50%. Here in the question you have seen the degree of reaction is equal to 50%. Now we know that alpha 2 is equal to beta 1 and alpha 1 is equal to alpha 3. Alpha 1 from the stage velocity triangle, you know that this value of alpha 1 is equal to alpha 3. This alpha 1 is equal to alpha 3, and which is equal to beta 2, because it is equal to the stator exit. Therefore, we will be getting as beta 2, which is equal to 25 degree. We know this equations. Now, with this data, we should find the mass flow rate. Okay, that is the subdivision B, mass flow rate, which is equal to rho 1. Sanjay, rho 1 Px into pi dH1. Okay, this is mass flow rate. We know that mass flow rate is equal to density into the velocity into the area. This is velocity and this is area. Therefore, mass flow rate is equal to rho times Cx into pi dx1. Now, if you substitute this value, you will be getting the mass flow rate. But in this, the value of rho is unknown. So you should find the value of this density before finding the value as mass flow rate. Therefore, this density rho is equal to rho 1 is equal to P1 divided by RT1. We have the value of P1 and T1. That is temperature and pressure at the entry. Temperature is 300 Kelvin and pressure is 1 bar. Okay. Temperature is 300 Kelvin and pressure is 1 bar. By substituting this, you can get the value of density. That is, the value of density is given as P1 is 1 bar. Therefore, 1 into 10 to the power of 5 Newton per meter square divided by R is nothing but 287 into value of T is given in Kelvin itself. Therefore, you can directly substitute as value of T is equal to 300. Now, on calculation, the value of rho 1 will be 1.161 kg per meter cube. So, we have found out the value of density at the stage 1. Now, we know all other values, that is value of Cx is known, the value of D and H is given in the question. In the value question, that is the mean blade ring diameter is 36. Mean blade ring diameter is 36 centimeter. Therefore, it will be 0.36 meter, and the blade height at the entry is given as 0.6 centimeter. Therefore, it will be 0.06 meter. Okay, we have both the value of diameter and the height. By substituting this is D1 and this is H1. By substituting this value, you can get the value of mass flow rate. Therefore, mass flow rate will be equal to
இல்லைங்க சார்.
mass flow rate, which is equal to, we have find out the value of rho as 1.161, and if you substitute the value of rho as 1.161 into the value of Cx is 180, the value of Cx is 180, that is, you can see axial velocity is 180 meter per second. Axial velocity, which is nothing but the value of Cx is 180 meter per second. By substituting this, you will be getting the value of into 180 into 180 into pi into 0.36 into 0.06. That is, this is the diameter D1 and this is H1. This is Cx and this is the value of rho. Okay, this is the value of rho. Now on calculation, the value of mass flow rate, will be equal to 14.18 kilogram per second. Therefore, mass flow rate is equal to 14.18 kilogram per second. Okay, this is how we will be attaining, or we will be deriving attaining the value of mass flow rate. That is, mass flow rate is equal to rho Cx pi into dH1, where Cx is the axial velocity, which is given as 180, and D and H is given, where D is 36 centimeter, which is equal to 0.36 meter, and H1 is 6 centimeter, which is equal to 0.06 meter. And we have find out the value of rho 1, where value of rho 1 is equal to P1 by RT1. By substituting these values, you will be getting the value of 1.161 kg per meter cube. Now, we have substituted all this value in this equation and we have attained the value of mass flow rate. Next, you have any doubt till this? Can I doubt regarding?
No, sir.
Next, we should find the value of power required to drive the compressor. We should find the value of power required to drive the compressor. Okay. That is subdivision C. We should find subdivision C, which is nothing but the power required. We should find the power required. The power required is given by a formula P, which is equal to 1 by neta m. 1 by neta m is the mechanical efficiency into mass flow rate into work done. Okay, this is given by power required is given by P is equal to 1 by neta m into mass flow rate into W. Now, the value of W is given by an equation. The value of W is given by an equation. This is sigma U Cx into tan beta 1 minus tan beta 2. Okay, tan beta 1 minus tan beta 2. Now, this value, that is this value omega is nothing but, it is a work done factor, which is the work done factor, and it is given as 0.88. Okay, it is given as 0.88 in the question. So by substituting this value, you can get the value of W. That is, this is nothing but the value of omega, which is the work done factor. Therefore, by substituting this, you will be getting work done factor is equal to 0.88 into the value of U. We have already found the value of U is equal to 339.292. By substituting that, you will be getting 339.292 into Cx is equal to 180. That is, the value of Cx is 180. It is 180 into tan the value of beta 1 minus beta 2. That is 180 into tan beta 1 minus beta 2. We have value of tan beta 1. We have find out the value of tan beta 1 is equal to 1.418. Okay, we have find out the value of tan beta 1 is equal to 1.418, and the value of tan beta 2, we have value of beta 2 is equal to 25 degree. We have value of beta 2 is equal to 25 degree. Therefore, this value of tan beta 1 is, we can write tan beta 1 minus tan beta 2. Okay, the value of tan beta 1 is equal to 1.418, and the value of tan beta 2, which is tan 25 degree, which is equal to, on calculation, tan 25 degree will be equal to 0.466. Okay, therefore by substituting this value in the above equation, you will be getting 0.88 into 339.292 into 180, and the value of tan beta 1 is 1.418 minus 0.466. Okay, now we have substituted all these values. That is, this is omega, and this is the value of U, this is the value of Cx, this is tan beta 1, and this is tan beta 2. Okay, we have substituted all the values in the corresponding equation, and on calculation the value of W will be equal to 5164.15 joules per kg. Okay, you will be getting the value of W is equal to 5164.15 joules per kg. This is how we have attained the value of W. Okay, do you have any doubt? S biology, உங்களுக்கு doubt இருக்காப்பா? The value of W attain பண்ணதுல S biology, பாலமுருகன்.
Yes, sir. Biology, sir.
பாலாஜி, டவுட் இருக்கா அதுல?
No, sir.
எல்லாம் புரிஞ்சுதுங்களா?
Sir.
பாலமுருகன்.
சார்
எல்லாம் புரிஞ்சுதா? ஏதாவது டவுட் இருக்கா அதுல?
சார் இல்லைங்க சார், புரிஞ்சுது சார்.
எல்லாம் புரிஞ்சுதா? Okay. Now we can substitute the value of W in this equation. That is, we can substitute the value of W in this equation, and you can attain the value of power required. That is, power required P is equal to 1 divided by neta m, which is the mechanical efficiency, into the mass flow rate into the work done. Okay, therefore the value of P, power required, is equal to 1 by neta m mass flow rate into W is equal to mass flow rate. We have calculated mass flow rate as 14.18. Therefore, substitute 14.18 into the work done we have calculated as 51164.15. That is into 511 51164.15 when converted into joule. That is, here it is in joules per kg. That is 51164.15 joules per kg. And if we convert this into kilojoules per kg, the value will come as 51.164. That is, you can write 51. This is 51.164. This is in kilojoule per kg. This is in kilojoule per kg. Whereas the work we have found out in this equation is joules per kg, and dividing by 1000, you will be getting kilojoules per kg, and we have substituted in terms of kilojoule. This is in terms of kilojoule divided by, we have the mechanical efficiency as, which is nothing but neta m as 96.7%. 96.7%. Therefore, substituting 96.7% is 0.967. Okay, 0.967. You can attain the value of P is equal to 750 kilowatt. You can attain the value of P is equal to 750 kilowatt. Okay, this is how you can find the value of the power required. Okay, and the next subdivision is, the loading factor. The loading factor, which is given by psi. In the yesterday class, we have derived this equation, that is psi, the loading factor, which is equal to W by U square, which is W by U square. Therefore, we should find the next subdivision is the loading coefficient. Okay. The loading coefficient is given by an equation psi is equal to W by U square. We know the value of W. W is equal to 51.164 kilojoule per kg or 51164.15 joules per kg. Okay, you can substitute any of this value to attain the value of loading factor, and this is 1164.15. It is in joules per kg. Divided by U square. We have find the value of U is equal to, this is the value of U, which is 339.292. And if you substitute that, you will be getting 339.292 whole square. Okay, and on calculation, the value of W will be equal to the value of psi will be equal to 0.444. Okay, the value of psi is being derived as 0.444. Now we have found out the value of loading coefficient. Next, we have to find the pressure ratio developed by the stage. That is, here which is pressure ratio developed by the stage. Okay, we should find this value. Okay, this pressure ratio is being calculated from an equation which is delta T at the stage is equal to T1 into PR to the power of 0.286 minus 1. You just keep this equation in mind, that is delta Ts is equal to T1 into PR to the power of 0.286 minus 1 will give the pressure ratio, which will give the pressure ratio developed at the stage, which is equal to the neta stage into delta TA. Okay, neta stage into delta TA. Now, in this equation, you should find the value of delta TA. This value of delta TA is being calculated from an equation. Delta TA is equal to W by Cp. Okay, delta TA, that is the stage temperature rise, which is delta TA is given by W by Cp. We know the value of W is equal to, 51164.15 divided by the value of Cp is 1005. Okay, 1005 is the value of specific heat, and on calculation you will be getting the value of delta T of A is 50.91 degree Celsius. That is, the value of delta TA is equal to 50.91 degree Celsius. Now, this equation is nothing but the equation for isentropic temperature rise. This is an equation for isentropic temperature rise. Okay, which is nothing but delta TA. Okay, sorry, which is nothing but delta T of S. This delta T of S is the isentropic temperature rise, which is been given as an equation T1 into PR to the power of 0.286 minus 1, which can also be equated as efficiency at the stage into delta T of A. This delta T is the temperature, actual temperature difference. Now we have found out the value of delta TA. Now by equating this, that is delta T of S is equal to T1 into PR of 0.286 minus 1, which is equal to neta stage into delta TA is equal to the efficiency at the stage. You have the efficiency at the stage as 85 degree. This is efficiency at the stage, which is given as 85%, Therefore, on substituting, you will be getting 0.85 into delta TA is 50.91 degrees Celsius. Okay, and on calculation, if you substitute this value of T1 is, we know that T1 is equal to 300 Kelvin. That is, this is the value of T1 and this is the value of P1. That is, we know that T1 is equal to 300 Kelvin. By substituting this, you will be getting 300 into the pressure ratio to the power of 0.286 minus 1 into, this is the stage efficiency and delta TA, which is equal to 0.85 into 50.91 degrees Celsius. Now, on calculation, you will be getting the value of PR is equal to 1.6. The value of PR is equal to 1.6. That is, you should multiply this with this equation. That is, you will be getting 300 PR to the power of 0.286 minus 300, which will be equal to this equation, and this 300 will go on other side, and you will be getting an equation which is PR to the power of 0.286 is equal to 1.144. That is, you should multiply this value, and if 300 goes on the other side, you will be getting the value of 1.144. And this which goes on the other side will get in form of 1 divided by 0.286, and on calculation you will be getting the value of PR, that is the pressure ratio PR will be equal to 1.6. The pressure ratio PR is equal to 1.6. Okay, do you have any doubt till this, how we have calculated the value of PR? Gokulji, kana edha doubt irukungala? Gokulji, kana edha doubt iruka?
Yes, sir.
Karthik Kumar, கார்த்திக் குமார் இருக்கீங்களா? குமரேஷ்,
சார்
ஏதாவது டவுட் இருக்குங்களா?
சார் எதுவும் இல்லை சார்.
எதுவும் இல்லைங்களா? எல்லாம் புரிஞ்சுதுங்களா?
சார்.
And the next is you should find the Mach number at the rotor entry. Mach number at the rotor entry, which is M of W1. We should find this value. And the Mach number, that is F. This is, consider this as F, which is Mach number, which is given as Mach number. Okay, which is M of W1 is equal to, this is W1, which is the velocity of the flowing fluid divided by the velocity of the sound, and the velocity of the sound is given by gamma R T1. Okay, therefore we know the value of W1, which is given as 312.5, the velocity at the inlet W1, which is the relative velocity at the inlet. This you should find, this you should find. Okay, the value of W1 we should find, that is the value of W1 will be equal to, from the stage velocity triangle, if you take cos beta 1, this cos beta 1 will be equal to the opposite side, the adjacent side by the hypotenuse. Cos beta 1, cos theta is equal to adjacent side by hypotenuse. Therefore, adjacent side is Cx1 and hypotenuse is W1. Therefore, cos beta 1, this is cos beta 1 is equal to Cx divided by W1. From this, the value of W1 we can attain. Since we know the value of beta 1 and the value of Cx, which is equal to 180, you can attain the value of W1. Therefore, value of W1 will be equal to Cx divided by cos beta 1. Cx divided by cos beta 1, which is equal to Cx is 180 divided by cos beta 1. The value of beta 1 we have found it out. The value of beta 1 is equal to 54.82. And substituting this cos of 54.82, and on substituting you will be getting the value of W1 is equal to 312.5 meter per second. You will be getting the value of W1 is equal to 312.5 meter per second. Now, if you substitute the value of W1 in this equation, you know that value of gamma is equal to 1.4 and value of R is equal to 287 and value of T1 is given as 300. Therefore, by substituting the value of W1 in this equation, you can get the value of MW1. That is the Mach number at the rotor blade entry you can get. That is M of W1 is equal to 312.5 divided by 1.4 into 287 into value of T1 is 300. Okay, and on substitution you will be getting the value as 312.5 and this denominator you will be getting 347.18 and the value of MW1 will be equal to 0.90. Therefore, we have attained the value of the Mach number at the rotor blade. Okay. Do you have any doubt in this problem? Can I ask a doubt? We have find out all the subdivision which is given in the problem. Can I add doubt? Pradeep. Pradeep இருக்கீங்களா?